Hello everyone. This part of the module will talk about solution chemistry, and in this part we will discuss the following: Raoult's law and Henry's law. We will also discuss activity and activity coefficients, and finally we will have a review of colligative properties. So let's start with the first one. Si Raoult's law at si Henry's law, these are what we know as examples of limiting laws. Bakit sila tinagurian na limiting laws? So limiting laws, just like your ideal gas equation, they are true for certain conditions lamang. For example, for the ideal gas equation, there is a range of temperature and pressure kung saan applicable si ideal gas equation. Basically, applicable siya sa perfect gases. So, ganoon din sa solution chemistry, ganoon din sa solutions. No? Si Raoult's law tsaka si Henry's law, these are limiting laws in that they are only applied to ideal solutions. Okay? Ideal solutions. What do we mean by ideal solutions? So, one criterion para masabi natin na ideal yung solution. So, most dilute solutions are actually ideal solutions. Kasi pag sinabi natin ideal, well, there are no molecular interactions within the solution. Negligible yung molecular interactions. And that is true for dilute solutions, right? Lalong-lalo na kapag meron kang case of infinite dilution wherein you only have one particle or one molecule in the solution. So, wala talagang interaction doon. So, that can serve as an ideal solution. Now, what's the difference between the Raoult's law and the Henry's law? So, suppose meron tayo ditong solution, and let me draw it like this. Okay, and lalagyan natin siya syempre ng solvent. Let's say water lang yung solvent natin. Okay. So there. Tapos, dissolved in this aquatic or aqueous solution is some particles, no? So, molecules nakadissolve doon sa solution. Okay, what I'm doing really here is we wanna designate kung alin yung solvent tsaka kung alin yung solute. So pag sabihin nating solvent, siya yung mas nakakarami doon sa ating mixture. Right? So yung ating solvent will be this one. This is the solvent. And yung solute natin is itong mga to. No? Now, let's make some symbolism here. So, kapag solvent, okay, gagamitin natin yung symbol na B. Okay, so B will refer to the solvent. Or actually, we will use A instead. Sorry. Okay, let's use A for solvent while B will refer to your solute. So, punta ngayon tayo sa pinagkaiba ni Raoult's law tsaka ni Henry's law. So, si Raoult's law, it describes the dependence of vapor pressure of a solvent as a function of its mole fraction. Okay? Solvent ang tinutukoy natin kapag Raoult's law. Now, how do we express Raoult's law mathematically? Remember, yung B will refer to the solute and A will refer to the solvent. So therefore, for Raoult's law, we will use A. So ang gagawin ng Raoult's law is it will calculate the partial pressure of A. Okay? And it's related to the mole fraction of A or ng solvent times the vapor pressure ni solvent kapag pure siya. Kasi yung P sub A, it's actually the vapor pressure of the solvent pero nasa solution siya. Okay? So, ibig sabihin, related yung vapor pressure na yon doon sa partial pressure ni A with the concentration or specifically the mole fraction of the solvent. Now, si Henry's law naman, Kung si Raoult's law ay for the solvent, si Henry's law will be for the solute. Okay, so it describes the dependence of the vapor pressure of a solute as a function of its concentration. So mathematically, we want to find the partial pressure of a certain solute in a solution. So B ang gagamitin natin. So partial pressure of B, it is related to the concentration of B with a constant of proportionality. So yung constant na of proportionality dito, tawagin natin siyang K sub H prime. Okay? And then multiply this by the concentration of B. So, concentration of B. Now this constant right here, and let me highlight this equation. So there I highlighted the equation. Na-highlight ko na rin yung equation for Raoult's law earlier. So let me just clarify that this equation is for Henry's law. But anyway, yung K sub H dyan, yun yung tinatawag na Henry's law constant. Okay, what constants can you expect for calculation? So yung unit ni Henry's law constant, depende yan actually dun sa given na unit ni concentration. Kasi si concentration of the solute could be mole fraction, okay? Pwede ring molar, etc. So depende yung constant ni Henry's law doon sa kung anong klaseng concentration unit ang meron ka. Kasi sometimes meron kang ibang version ni Henry's law. Let's say you wanna calculate for the concentration of certain species I. Okay? So you can do it by using this equation. So you have a Henry's law constant without the prime times the partial pressure of that particular solute. So pwede natin yung gamitin. Depende nga lang yan kung anong klaseng unit of the Henry's law constant meron ka. So let me illustrate this by giving you an example. So let's consider this simple problem. You have to estimate the molar concentration of carbon dioxide in water at 400 kilopascal, or that's 4 bars, no? Ibig sabihin it's way greater than atmospheric pressure, which is approximately 1 bar. Now you're given the Henry's law constant for this carbon dioxide dissolved in water. So that's 3.01 times 10 raised to 3 kilopascal kilogram per mole. So if you take a look, if you inspect yung ating unit for the Henry's law constant, so naka kilopascal kilogram per mole siya. So malamang yung ating concentration na makakalculate dito is pwedeng kilogram per mole, right? So therefore, the equation that we shall use is, so we will use yung partial pressure of this solute A, right? Or B rather, okay? Kasi again, we use B for the solute. So the partial pressure of B is equal to the Henry's law constant times the concentration. Okay, basically. So, ang gagawin natin is we wanna calculate the concentration. So, concentration is therefore equal to the partial pressure of B divided by the Henry's law constant. Okay, so that will be 400 kilopascal over we're given 3.01 times 10 raised to 3 kilopascal kilogram per mole. So, ang mangyayari dito, ang makakancel lang sa ating equation will be kilopascal. So, ang matitira is kilogram per mole. Okay? So, what will happen is, ang magiging sagot dito numerically will be 0.132 moles per kilogram. Okay? Yung kilogram na, ibig sabihin niyan is kilogram of the solution. But let's assume na syempre yung solution natin is dilute, right? So therefore, the density of the whole solution is approximately the same or equal with the density of the solvent. Dilute kasi. So pwede mo siyang gawing, this is an aqueous solution, right? And water has a density of approximately 1 kilogram per liter. So this could also be equivalent to 0.132 moles per liter. So this is now the answer. Now, a follow-up question is, what if ang pressure natin instead is 1 bar? Okay, ano yung magiging molar concentration? So imagine you have a soft drink, no? And yung soft drinks, let's say, nasa can siya, sobrang pressurized niya. And again, let's consider na, halimbawa, 400 kilopascal or 4 bar yung pressure sa loob. So therefore, that's also the pressure of the carbon dioxide, approximately, carbonated drink. Right? So, nalaman natin na ang concentration is 0.132 moles per liter. Tapos, halimbawa, binuksan mo yung Coke in can. Ibig sabihin, your solution is now exposed to an atmospheric pressure equal to 1 bar. So, what will happen to the concentration? So, the molar concentration will therefore be, so susundan nyo lang yung calculation above, instead of 400 kilopascal, maging 100 kilopascal, divided by the Henry's law constant, 3.01, times 10 raised to 3 kilopascal kilogram per mole. So, ang lalabas na answer dito will be 0.033 moles per liter. And as you can see, higit na mas mababa yung concentration ngayon ng carbon dioxide doon sa carbonated water kapag na-open na to the atmosphere yung lata.